In the wild world of generative AI, one wrong move could expose your business to massive risks. Imagine an AI assistant accidentally revealing personal information, generating harmful content, or going completely off script. These aren't just hypothetical scenarios, they're real threats which are facing every AI-powered application. Hi, I'm Stuart. Today I'm going to show you how to build Amazon Bedrock Guardrails, your comprehensive shield against AI unpredictability. So I've decided to open a pizza shop. And my business is doing great. We have lots of feedback and we have some information on the feedback too. But a lot of this has customer personal identification or information in there. So let's create a guardrail for this. You can do this in one of two ways. You can do this via the AWS console, or you can do this with the API. The set is exactly the same. First, you create a guardrail by setting up the configurations, defining topics to deny, providing filters to handle harmful and sensitive content, and when writing messages for prompts and users, responses are then blocked. A guardrail must contain at least one filter and messaging for when prompts and user responses are blocked. You can opt to use the default messaging if you wish. You can add filters and build upon your guardrail later and add more following steps. You can do this by modifying the guardrail to configure all of your components that you're going to need within your guardrail. So let's go and set this up. I'm going to set this up in a Jupyter notebook using Python and the guardrail API. Here, we're going to focus on the main function, as this is where all of the cool stuff is really happening. The create PII guardrail function crafts a robust PII protection guardrail for AWS Bedrock. It does this by employing multiple sophisticated layers of data privacy configuration. By accepting here three core parameters: the Bedrock client, guardrail name, and the description. Here also, the function enables us to be really flexible with precise security and also implementation. The function's comprehensive strategy encompasses several critical protection mechanisms. It establishes custom blocking messages that clearly communicate when sensitive information is detected, ensuring that transparency in data protection is processed. At its core here, this function identifies and anomalizes crucial personal identifiable information types. This can include email addresses, phone numbers, credit card details, social security numbers, and physical addresses. Beyond the standard detection though, we could also integrate an advanced custom regex pattern specifically designed to capture more complex email addresses and formats, for example. Here though, the guardrail goes a little bit further and it extends its security by implementing high-strength content filtering against potential misconduct and incorporating a word policy which blocks specific sensitive keywords. It does this and creates multiple barriers against potential information leakage. This multifaceted approach ensures comprehensive intelligent protection of sensitive personal data across input and output scenarios. When our function is called, it creates the guardrail. And it does this and it creates a unique identifier or guardrail ID. This allows for precise tracking and management of our PII protection configurations. The returned guardrail ID here can be used for future reference or additional security management. Okay, so now we can run this code. And once we have the output, we want to copy some of the details for later to use in another piece of code. So once we have created our guardrail, we need to test this with some data. In this example, we can use a JSON-L file. This is a text-based file format where each line contains a valid JSON object. It's essentially a collection of JSON objects, each separated by a new line character. This makes this really easy to read and process, which is great for even large data sets. This JSON-L file contains customer feedback data for our pizza orders. Each line represents a single feedback record, including the customer ID, their feedback text, the pizza type, the rating, and their contact information. Now, additionally, there's a section for model input here. This provides instructions for our model to analyze the feedback. Here, this data will be used to train our model for sentiment analysis. It will also identify trends in our customer preferences, or it can improve our customer services. But you will see it contains a lot of information which we should really be keeping private. So now that I have this file, I've uploaded this to an S3 bucket. We need some of the details from our S3 bucket for the next step, for when we test our guardrail to make sure this is all working. So here we've had our guardrail set up. We need to put the following details here that we copied earlier. We have our guardrail ID and we have our S3 bucket details. We've added these to this new Jupyter notebook. The script here represents an advanced context processing and safety mechanism, which is designed to analyze our customer feedback using Amazon Web Services, Bedrock platform, and Anthropic Claude AI models. The primary objective here of this script is to create a robust and secure intelligence system for handling all of our sensitive input data, also while ensuring our content and safety performance have meaningful analysis. At the heart of this program is the Pizza Guardrails Python class. This class ensures that our customer data adheres to predefined rules before being sent to a machine learning module. It also identifies or has the identifier for the guardrail policy. This specifies this requirement field, kind of like a model input and metadata, and it defines patterns to validate data such as our email and our phone numbers and the personal information from our customers. The class has two key functions. The first, which is the apply_guardrail, validates input data, and if this is successful, it will send it to AWS Bedrock, where the guardrail policy is going to be then applied. The second is the invoke model with guardrails. This uses a validated data call to Anthropic Claude or the model via Amazon Bedrock. The model processes the data and returns a response that the program can use then for further actions. The code main function here brings everything together. It connects AWS services, retrieves our file called pizza_batch input 10 because I have 10 identifiable customer details. And it gets this from our S3 bucket. It processes each customer record. Then, for each record, it validates the data using the Pizza Guardrail class. And if all of this is valid, it will send it to the Claude model. The program then sanitizes the output by redacting sensitive information like other names, email addresses, and phone numbers before displaying any or all of the results. So let's take a small pause here whilst it runs, grab a coffee, and then see what our results are. Okay, now the results are in. Let's go over this. Let's explore how this program processes customer feedback step by step with a focus on Amazon Bedrock Guardrails, and how this ensures our data privacy is being redacted and all of our sensitive information is being kept secure. Looking at this output, we can start with the record ID 001. The script has applied the guardrail to validate the data. Once validated, it invokes the Anthropic Claude model. The input here includes the prompt summarizing the feedback, best pizza in town, which is great to hear. Now this is for a mushroom pizza with a rating of 1.0. Sensitive details like the customer name, email, and phone number are all redacted by Amazon Guardrails, replacing with a placeholder such as redacted. The model response highlights a contradiction though. Once our customer praises the pizza, their rating is extremely low. So there might be a possible explanation for this, which might include sarcasm, dissatisfaction with non-pizza aspects, or an accidental rating error. Here though, the analysis concludes that the clarification from the customer would help resolve this discrepancy. Once we've gone over the first customer, the script will then move to the next record. It will do this and so on, following the exact same pattern, keeping all of our sensitive data 100% safe. Throughout this process, though, Amazon Guardrails has played a critical role in safeguarding all of our customer data. It's ensured that no sensitive information such as names, emails, phone numbers are leaked during validation or even the processing. And it does this while enabling the model to solely focus on keeping the feedback for actionable insights too. Amazon Bedrock Guardrails works with a wide range of models, which include FMs supported in Amazon Bedrock. We can have fine-tuned models and self-hosted models outside of Amazon Bedrock too. User inputs and model outputs can also be identifiably evaluated for third-party and self-hosted models using the Apply Guardrails API. If you're interested in this, all of the documents are going to be linked in the description to get you started. And if you enjoyed this video and want to see even more hands-on technical content, be sure to like this video and subscribe to the AWS Developers YouTube channel. Thanks for watching.